us, this pilot plant is obviously not a commercial project, but more a learning exercise. So we don't define the success by the amount of CO2 we capture, but rather the experience we collect.
My name is Patrick Hübscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models.
You are listening to the fourth episode in the series Incineration in the Circular Economy. In the previous episode, I was talking to Benedict, Managing Director and founder of Wasteer. We discussed the value of data and how that can help to increase the efficiency of incineration, but also recycling plants. In this episode, we will learn how EEW captures the carbon that is released during the incineration process. As usual, you get the key learnings from this conversation through our newsletter. Just sign up via www.circularity.fm. As a qualified engineer, he has spent his entire career designing, building, and overseeing plant facilities. More than 6 years ago, he joined EEW, where he holds the role of Director Innovation. Welcome, Jörn.
Good morning. Hi.
Jörn, we want to talk about carbon emissions today, but before we do so on a professional level, I'm pretty sure you're super conscious of emissions also in your private life. How does it show in your daily life?
Yes, it affects all of us. And I had a small story in the morning when I went with my children to the kindergarten. We have already always the discussion about, okay, are we going by car or by bike? And today it was a little bit raining, and my daughter said, "Oh, I would like to go by car." And I said, "No, we will go by a bike." And yeah, that's the first thing. And also the children were thinking about it, and that's the point. I think it affects all of us.
Yeah, definitely. I have the same. I had the same. So with the older one, who's now nearly 3 years at school, so he doesn't discuss anymore. He knows it already. Yeah. So,
It's normally it's a short way, and it's not that much time. But of course, the car is easy. And
definitely.
Yeah,
definitely. If it's standing there.
Yeah.
Cool. From bike to car, let's get even bigger in terms of emissions and look at the plant level. Why are incineration plants emitting carbon dioxide in the first place?
it's because of the process. The CO2 is created when waste is burned.
Technically, the carbon is already embedded. It's already there before the waste gets delivered to the EW plant.
Yeah, and then in the plant, during the burning process, there is something at the end. We have the CO2, and it depends, of course, of the input of waste, what kind of CO2 will be there.
Yeah. Can you give us a bit of a feeling what it means? So how much CO2 are we talking about?
At EW, we have a capacity around 5 million tons of waste per year. And that means, as I said before, 1 ton of waste will be 1 ton of CO2. So that means we have 5 million tons of CO2 per year.
Okay. So, and I understood technically this CO2 is embedded already in the waste, depending on the kind of waste you're getting. The plants emit that emissions after the burning process. And our overall ambition as a society is to reduce emissions. So what are the kind of options you have or like a plant has to reduce these emissions that, as I understood, the carbon is there. Yeah, it's in the input stream already. So you can't ignore that. But how can you deal with these emissions?
At EEW, we are focused on CO2 capture after the combustion, the post-combustion process. And the CO2 will remove from the flue gas. So we will have, for example, amine scrubbing. It's a chemical process where we'll get out the CO2 out of the flue gas up to 95%. And then the flue gas, it's more or less clean out, or it's out of CO2. And that's the main focus we at the moment, because during the process or before the process, it's quite difficult to capture the CO2.
And when you say you're looking into that, what exactly is EEW doing there already?
We have bought a CO2 test plant. It's a container where we can test the whole process. It's a small container which an amount, let's say 500 kilograms per day, which we can capture. And at the moment, the container is in Delfzijl. And so we can testing it. It's a mobile unit. And after testing it in Delfzijl, or after tested in Delfzijl, we will go to the next site. We have 17 different incineration plant with 17 different flue gas cleaning systems with 17 different input will change. So we really have to think about, okay, what will be the influence and how can we manage it for every, or how can we manage it for the EEW, and what kind of solution is, so that we have the test unit. We will start in Delfzijl at the beginning. You will see it with my colleagues, and then to go forward to test and improve the technology under real conditions. It's quite important, and also to develop know-how at our staff and our workers at the plants. This is a new process, as I say. It's a real experience and this kind of technology.
Yeah, wonderful. Let's follow that lead, and let's loop in the colleagues from Delfzijl, and they will tell us more about the operations there. Eike, you're a member of Jörn's team and oversee the carbon capture pilot in Delfzijl. Before we look into the pilot, can you give us a brief description of what's going on in Delfzijl? So what kind of waste is the plant handling there?
Yeah, of course. In Delfzijl, we operate a waste-to-energy plant. That plant treats more than 500,000 tons of municipal and commercial waste annually.
Okay, so now let's look at this CO2. So how is this actually collected?
So in Delfzijl at the moment, we are using a mobile CO2 test facility. We call it CC Mobile because we plan on moving it from one waste-to-energy plant to another to test different flue gas compositions. And the process we are applying at the moment is a post-combustion carbon capture process, meaning we capture the CO2 after the fuel or the waste is burned. So after the incineration process, we already have a flue gas cleaning system to meet regulations on our flue gas compositions.
And the flue gas is, just to get that straight, is basically the gas that is created after the waste is burned, right?
Yeah, like in your chimney, the gas that comes out of your chimney when you burn your wood in your oven.
Yeah. Okay.
Right, and this flue gas is already being cleaned at the moment because we have to meet regulations. And this clean flue gas is then processed within our carbon capture unit. And we, at the moment, use a chemical process, which is called amine scrubbing. Amine is the chemical that likes to grab the CO2 from gases. And if you'd like, I can briefly take you through the process steps and explain what we do.
Yeah, let's do it.
So the first step would be cooling down the flue gas. Usually we have a flue gas temperature of around 100, 150 degrees Celsius, but the capture process likes temperatures around 40 to 50 degrees Celsius. So the first step would be just throwing water on the flue gas, cold water, to cool it down and prepare it for the upcoming process. The second step would be taking the cooled flue gas into the so-called absorber, which is a big reactor. If you drove past a chemical plant, you might have seen the silverish, shiny, big thermos flask, looking like the bottles you usually put your tea in. And it's the same for us. We have a 14-meter high silver reactor where we lead the flue gas into the bottom. The flue gas goes up the reactor, and from the top we sprinkle down the amine solution. So it meets within this column, and the liquid amine solution grabs the CO2 from the flue gas and goes to the bottom. And the flue gas without the CO2 escapes through the top of the absorber and goes back to our chimney. So then we have the CO2 captured in a liquid state that reacted with the amine. And now we want to have the pure CO2. So what we do is lead the liquid solution into the desorber column. No, we had the absorber, now we go into the desorber, and then we reheat the whole solution. We put, for example, steam into the desorber column, which is also a chemical reactor, and sprinkle the CO2 amine solution from the top and put in steam from the bottom, or apply heat from the bottom. So it heats up, and with heat, the amine doesn't like the CO2 anymore and releases it. So at the bottom, we have the pure amine solution again, and at the top of the desorber, we can lead the CO2 out to process it further or use it as we wish.
Okay, that actually sounds pretty straightforward. And it sounds like a powerful amine that you have there. Carbon capture is usually framed as high energy or energy intensive. Why is that?
So the capture process itself is energy intense because you need the steam or heat in the desorber to release the CO2 again from the amine. So you have to undo the chemical reaction that happened in the absorber, and it doesn't do it on its own. So you have to give it something to release it again. And this something is a lot of energy, and it can cost quite a good amount of the overall energy output of a power plant itself.
So that this is then one driver that also makes it so expensive.
Right.
Okay. And now, as we discussed with Jörn as well, so this is a pilot, and you chose a mobile unit to test it in different plants with different flue gas composition. What are the success criteria you're looking at to see if this pilot is successful?
Yeah. So first of all, for us, this pilot plant is obviously not a commercial project, but more a learning exercise. So we don't define the success by the amount of CO2 we capture, but rather the experience we collect. So we have on the one side the more boring raw data questions we ask. For example, which are the perfect operating temperatures, which are the best cycling amounts of amine. So you can set the pumps, how much amine they cycle in a circle, which is a very, very important number for the overall energy efficiency. But now you see it gets boring. But these are the hard facts we ask when we look at the process. But we also want to make the mistakes you can do with such a process on a small scale. So when we scale up this, for us, unknown technology, we already hopefully made all the mistakes on a small scale. And we want to share this experience. We want to share this experience not only within the EEW group with our colleagues on site and our colleagues in the engineering and commercial departments, but also with partners. For example, amine research people or authorities that are not very experienced when it comes to these processes. They can take a look at our process, see, okay, what goes in, what comes out, what do we have to look at, and how, for example, can we measure certain things. This is a very important question, for example, when you want to have a permit for such a plant.
Okay. And Eike, my last question, coming a bit back to the process, is so how do I have to imagine this CO2 look like? So it's in the air, it's invisible. Now you captured it. Is it green? Is it blue? What's the composition?
Of course, it's green because it's biogenic. And no, jokes aside, the CO2 comes out as it comes into the process. You can still not see it in the original state coming out of our process, but then it depends on what you want to do with it. So most certainly, if you want to transport the CO2 over long distances, for example, under the sea, under the North Sea, as Norwegians are doing it right now, you need to compress and cool it down to liquefy the CO2. So it actually has a liquid state, which has a couple of advantages compared to a gaseous state. For example, you can put more of a liquid CO2 on a smaller, on the same room compared to gaseous CO2. So the transport costs go down. But generally, when it comes out of our process, it's firstly gaseous. So you still can't see it, but it's pure and not in our flue gas anymore.
Okay, but I believe you. Yeah, I can't see it, but I believe you. Yeah. Okay, cool. Let's go back to Jörn and discuss what happens with the carbon you captured in this pilot, and what are the next steps. Thanks, Eike.
Thank you.
Jörn, we just heard from the Delfzijl colleagues how the mobile testing unit works there, and we learned that the carbon is kind of captured there. But what happens after it has been captured to the carbon?
In the test units, the CO2 is captured, analyzed, and evaluated. After currently we release back into the flue gas. But we are looking for partners who would like to test further use cases for that. The key question for us will be, what can we do with the CO2? Is it utilization, CCU, or storage, CCS? Both are currently economical challenges. We really have to think about it. But at the moment, we will capture the CO2 and think, okay, what can we do with this? And this is one of our challenges. And we're looking for partners and find solutions for this.
Okay, so technically right now you're taking a step-by-step approach. You already capture it, see how it works, how does it influence the process. And since there's no solution yet for using it, storing it, you release it once again. So it's a bit like status quo, but you get these learnings, and now you then want to explore what to do with the carbon.
Yeah.
Okay. And just to separate storage and utilization, to me it feels like storage sometimes even happen before utilization, because probably in an ideal world you can utilize the carbon immediately, but sometimes you have to transfer it. It has to sit there to be used. So storage seems to be a topic you have to think about in any case.
Yeah, the storage often is a long way to, I don't know, to the sea, for example, also in the Netherlands, but also in Germany, it's quite a challenge. How can we store the CO2? The first thing, okay, we have to capture it. That's our part. It's quite easy. But to store it, we need a transporting system. And this could be a pipeline or a train, but it's not existing at the moment. There's no pipeline. There will no pipeline in the next 2, 5, 10, or 15 years, I guess. So that's really one of our challenge. Okay, how can we transport the CO2 from the south? We have their incineration plants from the south to the north. It's quite a long distance, and how can we transport it? It makes no sense to transport it with a truck, for example. Yeah. Then we will produce CO2 to transport the CO2 which we would like to store. So the best thing would be a pipeline, but currently there's no pipeline, and in the near future there will not be no pipeline. And it's also quite expensive to transport it. Also, if there's a pipeline, it's quite expensive to build the pipeline and everything. So the question is, okay, how can we get a business case also for this storage process? If we have, for example, directly in the neighborhood, somebody who needs CO2 in this process, in the chemical process, and you can use utilization, it makes sense. But at the moment, there's no market for the CO2 really, which we can say, okay, look, EW, we captured 2.5 million tons of CO2, for example. That would be the amount we have to do to be climate neutral. And how can we do that? If there's no need at the market to have 2.5 million tons of CO2, because for the process, as I said before, the amine scrubbing process need a lot of energy.
Right.
We need steam. And the steam we can, of course, use to produce electricity or to produce district heat or to deliver it to some customers. So that always depends. What are we doing with our steam? For example, when we have an incineration plant we need 20 or up to 30% of the steam to capture the whole CO2.
True. I start to understand the complexity behind that.
Yeah, and then that's only how we capture it. But then you only have to capture, you only have to transport it and to store it, and this is quite expensive overall, the cost. And yeah.
So technically, right now the infrastructure to transport it is missing, and also there's not much demand right now. But to me, it sounds like, so if I recall the conversation I had with Sebastian about where the waste incineration sits in the industrial system and the energy system, it was interesting to learn that it's kind of an industrial symbiosis between waste incineration and some industrial companies that need, for example, steam, or municipalities that need heat. And so it's a bit like a regional question also. And as you mentioned, that could also be a part of the future for carbon, that you don't want to transport it over hundreds of kilometers. Ideally, you have someone who consumes it, uses it next door.
That's quite hard. But when we talk about the steam and district heating, for example, district heating you will need in January, February, maybe in December. That will be the coldest month. But the rest of the year, you can use the steam for carbon capture.
Yeah.
So you don't have to say it's only this way or this way. You have to find a solution for both things. But at the end, it's a big challenge for us.
We talked a bit about the geography, and we learned about the Delfzijl pilot. Why is it running in the Netherlands and not in Germany first?
There we have already the most advanced and developed, and we have good local conditions and infrastructure, and the site allowed us to start quickly and efficiently, so that we start, okay, here we will start with our test unit, but the next steps will be in Germany.
Yeah. Okay. And I was wondering if regulation was one of the motivators, which brings me to my topic, because I mean, sometimes for people who follow the conversation, regulation seems to be an issue. It's a rather new topic. Many companies are exploring it. And of course, like, regulation also has to pick up what are the changes in regulation that are necessary to make it an affordable instrument.
We need clear and a framework, a regulatory framework. We need the pipeline, we need the infrastructure. As I said before, we need potential some storage where we really can use it also in Germany. We need, that must always develop. We need, okay, what kind of specification is necessary for the pipeline, for example, also discussion. So the whole framework for the whole process, that we get a business case for the process. At the moment, there's no business case. And the main question is, what can we do with the CO2? But if there's no framework, also political and economically, then there will not be no CO2 capture unit, because it's too expensive at the end. Yeah. And if there's no business case, nobody will do it.
Yeah, sure, for sure. And as it became clear, together we are at the beginning here, and EW is trying out how to deal with it. And with every new step, you have probably 5 more questions and the need for additional expertise and partners. So can you give us some examples of unsolved challenges where you look for partners right now, and where some of the people who are listening right now might reach out to you and say, hey, we could contribute?
One of the challenge, of course, is to find the right technology for the carbon capture process. As I said before, we only see at the moment amine scrubbing for the technical readiness level that we say, okay, we can scale it up, and it could be, let's say, 100,000 tons per year we can capture with this kind of technology. But this technology, we need a lot of steam and a lot of energy. So if there of course are other developments, and we are already doing a lot of technology screening at the market. There are technologies which not use that much energy for the process. That was of course helpful for us to find a better technology that we can use less energy for the process. That of course is one challenge, and to develop this kinds of technology would also be one of our part, and we are looking at the technology screening with my team, what we can do there. And on the other part, as I said before, it's one of our challenge, what can we do with the CO2? And if there is somebody who said, okay, we need a lot of CO2 and I really have a good solution for the CO2. For this, we are looking forward for some partners and develop some new technology also in this part, because this will one of our main challenge, what can we do with the CO2? In the near future, especially, and also in the next 10 or 15 years. And this is a problem for all of us to find a good solution, because all the process will be there. There will be waste, and the waste will be burned in our incineration plant, and there will be the CO2. But we have to capture it, and we have to find good solution for it.
Okay. Yeah, wonderful. So if you're out there listening right now, and
Yes, please.
have some solutions to capture, utilize, or store carbon, reach out to Jörn and his team. Jörn, thanks a lot for giving us these insights and for your work in capturing carbon.
Yeah, you're welcome. Thanks a lot.
This was the 4th episode of the series Incineration in the Circular Economy. You get the key learnings from this conversation in a one-pager, which you can access through our newsletter. Just sign up for it at www.circularity.fm. In the next episode, we will look at the sustainability report of EEW, and especially the discussion about landfilling versus waste incineration. But in between, there will be a special episode, the anniversary episode 100 of Circularity FM, and a surprise guest. Until then, stay tuned, drive a profitable circular economy, and please don't forget, the most abundant renewable resource is your imagination.
My name is Patrick Hübscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models.